Alright, for this lovely video, we're going to go over the definition of a logarithm and take a look at some really basic logarithm problems to get us started on this lovely magical journey of exploring logarithms. So, this is the basic mathematical definition of a logarithm. This expression would be pronounced log base b of x equals y. So log, this is a little subscript here, is going to be the base. We just use b for base. It'll be numbers in most of the problems. X equals y. And this double-headed arrow here is just a quick little symbol for if and only if. B raised to the power of y equals x. So this is the exponential form of the equation. We're probably real familiar with equations of this form. This is probably brand new, but all the variables are the same. So please note over here on this side, the logarithm expression, y is equal to the logarithmic expression. Well, what is y after all but the exponent? So sort of another way of thinking about logarithms, it's kind of effectively asking the question, what is the exponent power that some base is raised to get some number x? Let me take a look at a couple super duper basic examples in a couple videos coming up. You're going to see some advanced properties of logarithms, some really neat things we get to do with them. But let me start off with a super duper duper basic example here. And then we will slowly build sophistication as we go. So if I asked, for example, what is log base 3 of 27? I'll just set some random variable, y. These are arbitrary, by the way. They don't have to be b's, x's, and y's. They could be anything. R, q, whatever. So let's closely follow this definition. What I would suggest in the beginning, we'll learn more strategies soon, but in the beginning, let's use this definition, and basically we're just going to rewrite this logarithmic expression into the exponential form, which hopefully we're more familiar with and will make a little more sense of this problem. So the subscript b, the base of the logarithm, when I look over here at the exponential equation, b is the base that the exponent is being raised to. So the base is going to be 3 when I convert to exponential form. And then the y, the thing all by itself on the equal sign in the logarithm equation, is the exponent in the exponential equation. And then we have our equal sign, and then the answer in the exponential form is this number that's at the end of the logarithmic expression. So in this case, that's just plain old 27. So log base 3, 27, is effectively asking, what exponent power do I raise 3 to get 27? And if you use this definition and just substitute the base, the x value and the y value, and convert it from logarithm to exponential form, then it becomes a little clearer. Well, at least an equation you should be somewhat more familiar with. What exponent power do I raise 3 to get 27? And since 3 cubed is equal to 27, then y equals 3. So log base 3 of 27 equals y. Log base 3 of 27, excuse me, equals 3. We will take a look at a couple other properties in some subsequent videos. All right.